Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm Mohammad Syakir Abdol Salam from Mechanical Engineering 1, and today I would like to present about the effect of a liquid's density on an object's buoyancy. In my presentation, I will be discussing on a few elements. The first one will be introduction, the second one will be objectives and methodology, the third one will be the setup, the fourth one will be the results and discussion, and the last one will be the conclusion for this experiment. So I will be go through one by one. For my introduction, buoyancy can be described by Archimedes' principle, which states that any object fully or partially immersed in a fluid is buoyed up by a force equal to the weight of the fluid displaced by the object. Some objects, when placed in a liquid, float while others sink, and some neither float nor sink. This falls under the function of buoyancy. Things that float are considered as positively buoyant, while things that sink are considered as negatively buoyant, and things that neither float nor sink are considered as neutrally buoyant. So this is the formula of Archimedes' principle, which is Fb equals to rho FLVG. These formula are very important for my experiment. Next, for my objective for the experiment is to determine how the density of different liquids objects the buoyancy of different objects. Next, this is my setup for this experiment. So for liquid, I'm using alcohol and salt water. Next, we move to the procedure for this experiment. So I will follow the 14 simple steps to make sure this experiment runs successfully. I will be go through one by one. So first, weight the two weights both individually and combine and document the results in gram. Next, weight the weights in the various liquids using a spring scale. Next, pour the various liquids into 250 ml beakers. Next, attach the weights to the hook of the spring scale and lower them carefully into the various liquid. Next, the weight of the weights measured using the spring scale is then recorded in grams and compared to the weight of the weights as earlier recorded using the electric scale. Next, the difference in these two recorded weights represents the buoyant force of the object. To determine the density of each liquid, weigh an empty 10 ml graduated cylinder. Next, pour a given volume of liquid into the cylinder and weigh. Next, the liquid's weight is then calculated by subtracting the weight of the cylinder from the total weight of the cylinder containing the liquid. Next, the density of the liquid is then calculated by dividing the mass of the liquid by the volume. Next, for each liquid used, pour an amount into the spill can so as to fill the can to the highest level possible without causing the liquid to spill over. Next, place a graduated cylinder or beaker at the end of the spill can spot to catch the liquid. Next, slowly lower the weights into the liquid, allowing the displaced liquid to spill out into cylinder or beaker. Last step is measure and document the amount of liquid that is displaced. Next, we move to result and discussion. So I managed to get weight of object, weight in fluid, buoyant force, and weight of displaced fluid for both alcohol and salt water. As you can see here, the weight in fluid alcohol is greater than weight in fluid in salt water. The buoyant force of alcohol is lesser than buoyant force of salt water, and the weight of displaced fluid is lesser than the weight of displaced fluid from salt water. So the result I obtained indicate that the denser the liquid, the less the object will weigh when placed liquid the fluid, and consequently the more buoyant objects become. Alcohol had the lower density than salt water at 0.87 gram per mil. As a result, it caused the object to weigh more than it would in liquids of higher density. In the case of salt water, which has a density of 1.02 gram per mil, the weight of my object in the liquid was less than the same object's weight in alcohol, indicating a higher buoyant force. So we can conclude the higher the density of liquid, the more buoyant an object placed within it becomes. Thank you.